So I don't want to forget to record. So there we go. All right. So yeah, so you do want to have your project space presentation packet handy because you are going to be filling that in. There's only 2 more presentations left. Today is number 8, Universal Law of Gravitation. And Alex, Chase, and Zane did a fantastic job with their presentation. So I'm going to be doing that today. And then you can ask them some questions. We also are going to, they have a Kahoot for that. But before we do the Universal Law of Gravitation, we got together, which was Thursday, last Thursday. We watched the presentation by John, Ben, and Elish and Zeke called the Space Program, and we haven't taken their quiz yet. So we're going to start with their Kahoot quiz. So have your phone ready to play Kahoot if you can. If not, it's okay. It's not required, but it's fun. And then we will also play another Kahoot after we watch the presentation on gravity. Want to be aware of some things that are going to be due. We haven't had anything to be turned in lately, so your grades have been a little bit stagnant. Oh, speaking of grades, most of you have your project grade. It's been graded and put in EDSB, and I sent you your rubrics. Some of you haven't gotten that yet, and I'll finish that tonight. So all your projects should be graded by later tonight, and grades in EDSB, and a copy of your rubric on how I graded you. So be looking for that in the, today, tonight, tomorrow morning. And then you're going to have a test on the information on Thursday. 30th is going to be our test. So there is a study guide that I've put on EDSB, and that study guide is going to be due next Tuesday. And you're also going to be submitting your presentation, your project space presentation packet that you've been filling in during the presentations. That's going to be due this Friday by 8 p.m. And then, like I said, the study guide is due the following Tuesday, which will be next Tuesday. And then we will, next week on Tuesday and Thursday, we will have reviews. So we'll be playing games and reviewing our astronomy units, and then after class, you'll take the test on Socrative. So 2 submit boxes are already on EDSB, the one for this presentation packet and the study guide. All right, anybody have any questions on what's due when, turn things in? That's next. Anybody raise your hand if you do. I am looking, not seeing anybody have any questions. Okay, great. That's good then. So today, like I said, all you need out is your project space presentation packet and your phone for Kahoot. And we're going to start with, well, we're going to do Kahoot right after you watch this video. So hopefully you will be able to see it in a second. Okay. Okay. Let me share. Okay. Hopefully you can see this. And let me make sure we've got video, sound, and all of that. Okay. All right.
When we look back at Earth from our unique perspective, mountains.
Just wanted to make sure we can see it. August, can you see this video on the screen right now?
Yes, I can.
All right. Okay, excellent. Thanks, August. All right, let's make this a little bigger. And start it from the beginning. Okay.
When we look back at Earth from our unique perspective from space, we're reminded that it is a beautiful oasis in the universe, a planet full of towering mountains, frozen landscapes, painted deserts, a planet teeming with life, one big ecosystem of which we are all a part. NASA's investment in space, the unique Earth science conducted from orbit and the technology developed by living in space and exploring our solar system and universe, returns benefits every day to people around the world. People working to protect and sustain Earth's environment. People helping communities to thrive. NASA collects data from a fleet of Earth-observing satellites orbiting the planet 24 hours a day, 365 days a year. We collect data from Earth-observing instruments on the International Space Station, aircraft, boats, and on land. We use and share that data to better understand the planet's interconnected systems and improve life on Earth. Innovations we develop are broadly available to industry and the public and have cleaned up oil spills, propel wind turbines, purified drinking water, and more. We use our vantage point of space to monitor the health of crops, predict droughts and floods, to help engineers and planners mitigate the effect of sea level rise, map changes in land ice. We track wildfires, chart hurricanes, and diagnose air quality. But more than just observing these phenomena, NASA provides near real-time data to first responders and decision makers to provide help when it is needed. Every day, cutting-edge technologies are being developed as we prepare to send the first woman and next man to the moon. Technologies that will someday benefit life on Earth. And as we explore the moon and Mars, we will learn more about Earth, inspiring us to be better stewards of our home planet. As NASA joins the world in observing the 50th anniversary of Earth Day, we reaffirm our commitment to understanding our planet's interconnected systems and to help protect them for future generations.
Okay. All right. So hopefully you were able to view that whole video. At one point, it stopped on my end, but I think it played. Hey, Alex, did the whole video play?
It was paused a little bit, but we got to see the ending, yes.
Okay. All right, great. Oh, technical difficulties are so fun. Okay, so hopefully you were able to see that. And I thought that that was really fitting for today being Earth Day, and also, you know, John, Ben, and Elish, and Zeke were just teaching us about, you know, what NASA is doing up there in space and about the satellites, and maybe not all that the satellites are doing, but I thought that they definitely related to what we were talking about. And as you can see, I've got, I went up and got the background from my classroom, and we have to clean out the classrooms and stuff. So anyway, I got background now. And this is my Sir Isaac Newton shirt. We will see if you can figure out why I am wearing this shirt today later on. So, okay, we're gonna play Kahoot now. So go ahead and get your phones ready. This Kahoot is brought to you by John, Ben, and Elish, and Zeke. And we should hopefully be able to see it. Actually, maybe not quite yet. Let me actually pull, I gotta get the other video off of there. Okay, now, smaller, okay, yeah. Sorry, I'm talking to myself. Okay, let's see. We are gonna have a new share so you can actually see my screen. Okay, all right. Now we have our Kahoot up here. All right, so this should say the space program Kahoot. I hope it does. Is that what we're seeing? Eli, are you seeing our space program Kahoot showing up now?
Yes, it says classic or team mode too.
Yeah, okay, thank you very much. Have to keep checking because I just want to make sure you guys are seeing what I'm seeing. Okay, so we're gonna play classic. Now, I want you guys to make sure that you put in your name not a nickname, just like we've done in the past. I heard that Miss Hickey had a little bit of an issue with Kahoot today, people botting it and also putting in inappropriate nicknames. So please don't do that. I can block them, and don't have them blocked right now, but if I need to, I will do that. Okay, so thank you guys putting in your real names. I appreciate that. No bots. And I think there's 18 of you here. Not sure if everybody's playing. And then you feel free to use your notes on your Project Space presentation packet. This goes with project number 7, the space program. And let's see. Raise your hand if you need more time. Let me see. Where's my participants? Okay, so I am looking to see if we're done or if everybody has. Yes, if you are still trying to get in and you haven't yet, if you could maybe put your hand up for me, I'll know that I need to wait a few more minutes. All right, I don't see anybody's hands up, and it looks like we've got many people, 19 people here in the Zoom with us and 14 people playing. So, okay. Well, it looks like that might be all that's playing, and that is okay. Oh, Emily's joining us. Okay, let's get Emily in here. Welcome, Emily. We're glad you could join us. I apologize if my Zoom code issue earlier caused you to be signing in this late, but we haven't started our Kahoot game yet. You missed a short little video for Earth Day and our agenda for today, but other than that, you haven't missed much. So go ahead and get in there if you'd like there, Emily. And Emily, if you're gonna play Kahoot, but you need some time to get in, could you just raise your hand for me and I'll know to pause? If you don't raise your hand, that means that you're not playing, you're just gonna watch and I can start. Okay, I see your hand, so I'll wait. Okay, I'll let Emily get in. And then again, for those of you that are just joining us, this Kahoot is the space program brought to you by Zeke, Elish, and John Ben. And this is project number 7 in your packet. All right, Emily's in. Okay, anybody else need me to pause? Doesn't look like it. Okay, very good. So here we go. I'm gonna get rid of your text box so it's not in the way for us. Okay, all right. So here we go. All right, what was the space race? Is it a series of competitive technological demonstrations between the United States, or a competition where people race rockets, a race to see who could get to Mars first, or NASCAR in space? All right, it was a series of competitive technology demonstrations between the United States and Russia, we could have put there. But yeah, most of you got that correct. Okay, let's see who's on the leaderboard. John Ben is in the lead, and of course this is his Kahoot. And followed by, oh, this was supposed to be somebody. Okay, you're gonna have to tell me who you are or I'll have to kick you out because I said to use your real name. So who is this? Speak up now. No? We don't know? Who is this symbol right here? Let me see. You can raise your hand in the chat and I'll look. I want to know who you are. Otherwise, I'm going to have to kick you out. I'm sorry. But those were the rules. Nobody's raising their hand. And you're in second place. Are you sure? It's this little symbol right here. All right. Bye-bye. Okay. Ah, now you're telling me. um, what? You think it's Liam? Okay, well, Liam will have to sign back in. I think, Liam, you can still sign back in, but just use your name, please. That's what I asked you to do. It wasn't you? Okay. All right. Well, we'll move on then. Sorry that I kicked somebody out, but you have to make sure you follow the rules. Okay, coming up next, we got which country was the first to send a man into space? Was it the Soviet Union? Was it Russia? Was it the United States or was it Japan? All right, 3 seconds. And the Soviet Union. That's weird. How do I get that up there? I'm sorry if you can see this little sidebar that just popped up. I don't know. That's never shown up before. Okay, so the Soviet Union. And by the way, the Soviet Union is Russia. Russia used to be called the Soviet Union. So can somebody tell me if never mind. I've just got to get these out of here. Okay, there. So that gets out of the way for us. Okay, sorry about that. All right. Okay, so Alex has now moved into the lead. I don't know if that's Alex B or Alex S. We got Nova, we got Henry, Josh, and August. Alejandro is moving up there too. So, all right. Okay. Oh, it's Alex S. Okay, gotcha. All right. Okay, so which country landed men on the moon first? Was it the United States or Russia, the Soviet Union, or Japan? What do you think? 3 seconds. And the United States. And if you recall, that was when Neil Armstrong and Buzz Aldrin and Mike Collins went to the moon in 1969. Trying to move that out of the way here. Okay, so Alex is still in the lead now, but not far behind him is Nova, and Henry is right there on her tail, followed by August and Maddie. And August is on an answer streak. Okay, cool. So question 4, how's the ending of the space shuttle program affected Florida? All right, so has it hurt Florida's economy? Has it caused new shuttles to be made? Has it created jobs for many Floridians? Or did it cause NASA to shut down? Ooh, that's a hard one because I gotta say there's more than one answer that would be right there. So it did hurt Florida's economy. However, it did with the reinstatement of some of these private sectors that are helping NASA, it has actually created new jobs as well. It did not cause NASA to shut down. I had to look at the other one because NASA's still up and running. They actually made you the video that we saw today. So Alex is still in the lead, followed by Nova, and then August, Henry, and Saya's on the board. All right. Halfway there. What is a space shuttle? Is it a reusable plane like spacecraft? I'm sorry, a reusable plane like spacecraft, or is it a rocket made by SpaceX, or is it a train that goes through space? It is a reusable plane-like spacecraft, and most of you knew that. But a few of you thought that it was a rocket made by SpaceX. So SpaceX is making rockets now, but the space shuttles were was NASA specifically. And then when the space shuttle program shut down in 2011, SpaceX started coming in and making some new rockets. So, all right. All right, Maddie is moving up on the board, and Alex is still in the lead, followed by Nova, August, Maddie, and Henry. Okay. All right, question 6. What's the International Space Station? Is it a large satellite in low Earth orbit used for research? Is it an array of telescopes used for observing deep space? Is it a launching area on Earth used by all countries? Or is it a settlement on the moon? It is a large satellite in low Earth orbit used for research. And most of you knew that. Yes, it is only about 250 miles, I believe, above Earth, and it is in orbit. And we have lots of research happening there with different scientists. And we are hoping that at one point we actually might use it as a launch pad to go to the moon. Okay, so next question. What is a spectroscope? Is it a tool that refracts light into its spectrum? Is it a camera used on the space station? Is it a type of telescope, or is it Hubble? Spectroscope. We did a lab using spectroscopes. Luckily got that in before COVID hit. Yeah, most of you knew that it was a tool that refracts light into its spectrum or into its different wavelengths. So we had those little spectroscope cardboard little tools that we looked through, and we burned different chemical elements, and you looked at the light that they produced through the spectroscope, and you saw different energies or different wavelengths of light. And you learn that every element has its own unique spectrum. So they can identify what stars, what elements are in stars by using them. All right, so Nova's now in the lead. All right, a little bit of change in the leaderboard. Alex got knocked out by Nova, down, not knocked out, just moved down. And then Maddie is in third, August, and Saya. All right, going up to the last couple questions. What does a telescope do? Does it refract light to magnify images? Does it create spectrums of light for us to see? Or does it use cameras to magnify images? Three seconds. Yes, it is a tool that refracts light, that magnifies images. It refracts the light, and then it usually has two different lenses in it. Then shines the light onto a lens that then magnifies the image. Yes. So, depending on if you're a refracting telescope or a reflecting telescope, some use mirrors. Reflecting uses mirrors. Refracting uses two lenses. Okay. So, last two questions. What was the first U.S. satellite? Was it Apollo? Was it Explorer 1? Was it Challenger 2 or Saturn 5? The first U.S. satellite. Three seconds. Some of you had a little issue with that one. Okay, Explorer 1 was the first U.S. satellite. Hi, Nick. Welcome. Glad you could join us. So we are just doing our last question on Kahoot. And it looks like August is just taking the lead by quite a bit too. Well, got a decent lead there, followed by John Ben, and then Nova got knocked down to third place here. Maddie in fourth, and Saya in fifth. All right, last question. What is Hubble? Is it a satellite we use to see space? Is it a telescope we use to guess the age of stars? Is it a camera that we use on planes or a big plane that flies in space? 3 seconds. All right, it is, oh, there were 2 different correct answers here. It is a satellite we use to see space, and it's a telescope we use to guess the age of stars. Yes, so the Hubble is called Hubble Space Telescope. So it is a telescope, and it is in orbit around the Earth. So that is why it is a satellite. Remember, a satellite is any object that orbits a larger object. So Hubble Space Telescope is a satellite because it orbits Earth. Okay, so let's check out the podium. All right, Nova took 3rd place, and John Ben 2nd, and 1st is August. Nice job. And honorable mentions Maddie and Saya, and taken 4th and 5th place. Okay, excellent. I'm going to give you Dojo. I have no idea if that does anything anymore, but hey, why not? Giving it to you anyway. Okay, thanks, guys. All right, so welcome back. All right, so there's 21 of you guys here with us now, so that's a little bit better. A few of you joined us recently. So we just played the Kahoot by John Ben and Zeke and Elish. They did the space program presentation for us last week, and that was their quiz. So now we have 2 presentations left. We're going to do one today, and we're going to do one on Friday, which is our next class. So today's project number 8, which is the universal law of gravitation. So you want to have your project space packet ready for that. Courtney's coming to join us. All right. Hi, Courtney. Glad you made it back from our Zoom snafu earlier. I'm glad you could join us. We just finished doing the Kahoot for the space program, and now we're getting ready to do project number 8, brought to you by Alex, Chase, and Zane, Universal Law of Gravitation, which I'm gonna put the guys on the spot right now, and it is totally fine if you do not know the answer to this, but I'm just curious. I'm going to ask you, Alex. So who came up with the law of universal gravitation? Do you know what scientist?
Sir Isaac Newton. Sir Isaac Newton.
Yes, Sir Isaac Newton, and that's who's on my shirt today. So that's, and actually in comp science earlier today, we were learning about Newton's laws of motion. So it is a Newton day today. And for those of you who joined us a little later too, I was mentioning that our lovely and beautiful fluffy bunny Newton could really use a home. So if you would like to adopt Newton, or you know somebody that would, I would love to give him a good home. He's been so friendly lately too. He's not biting me. He's wanting to snuggle. I just can't have him in my house with the dog and the cats. So I want to give him a better home. So if you know anybody, please let me know. Yeah, okay. All right, so without further ado, we are going to get started on our presentation. Number 8. So don't forget to write your answers down in your packet. And also remember that Friday we're going to do the very last one, which is project number 9. And that's going to be brought to you by Reese and Saya and Zoe. And that'll be our last project. So we'll do that on Friday. And then Friday night by 8 p.m. you're going to turn your project packet in. Okay? So, all right. We're going to pull up the video. Let's see, might take me a second here to hoping. All right. Zane, are you with us today, Zane? I don't know if I've seen you yet. Zane and Chase. I know Alex is here. Oh, no, I don't see your other counterparts there, Alex. They left you. Oops. So, Alex, do you see on your screen, do you see a blank screen with the play button?
Yes, ma'am. Yes.
You do? You're on. And now you see your first slide popping up?
Yes.
Okay.
Yes, I do.
Perfect. All right. So here we go, everybody. And I guess your questions are going to have to be given straight to Alex when we're done, since I don't see Chase and Zane showing up. All right, here we go.
Good afternoon. I'm Alex Sabella. This is my me, Zane, and Chase's PowerPoint. I'll have Zane and Chase introduce themselves.
Hello, I'm Chase.
Hello, I'm Zane.
All right. Ours on my presentation was number 8, which is the law of universal gravitation, all about gravity. What is universal gravitation? Chase, would you like to explain this?
Universal gravitation is usually Newton's law states that every particle attracts every other particle in the universe with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In other words, every object exerts an attractive force and all other objects, but an object with greater mass exerts a greater amount of force. Example, an apple drops to earth because Earth doesn't jump up to the apple because Earth has more mass.
Right. The apple is pulling on Earth in the same way that Earth is pulling on the apple because they both have mass. However, because Earth has more mass, it pulls the apple to the Earth, and that's why it falls. All right.
All right, I'm going to pause for a second because I believe you have to write a definition for universal gravitation. So this first bullet is the official definition, and then the second bullet is kind of putting it in their own words, or in everyday words. Only thing that I don't see in the second bullet in their own words is that the distance also affects. So the further away two objects are from one another, the less gravity that they have. The closer together they are, the more gravitational force they have. And then, of course, the bigger the mass, the bigger the gravitational force, less mass, less force. There's an actual equation for this, and then what they wrote in the first bullet is the equation in word form. Okay, I'll move on, and then if you have another question about it, we can go back.
This is just an example of gravity. It's glass breaking.
I did watch it, and it was very loud.
So I guess they decided not to do the
That's
last.
around 3 minutes of him actually dropping glass. It's just an example of gravity. Right?
And we don't actually hear how loud it really is.
You get the idea. All right. No, I don't know how to actually.
I'm going to. There we go.
How did gravity actually help form the planets? Right. I mean, you hear gravity and you hear that the planets form, but how are those two things connected? Well, about 4.6 billion years ago, the solar system just a cloud of dust and gas, right? And that is now obviously known as a solar nebula. And obviously gravity pulls things closer together and everything, and it collapses things onto itself. So that's how the planets in the solar system was formed. Gravity collapsed the materials in on itself as it began to spin, forming the sun in the center of the nebula, because that was the most massive thing. It was the star, obviously. And then other particles collapsed on themselves to create the planets that then orbit around the sun. And we'll talk about how orbit, it creates how orbit happens later on. All right.
And I don't know if we needed to pause here, but basically, yes, so all planets and stars too start off as this like nebula of gas and dust, and then as they swirl around each other, gravity kind of starts pulling it in until it ignites and forms a planet or a star. So that's what he's talking about here. You probably don't need to write all of those details.
I have this pictures of what we imagine a solar nebula to look like. Obviously, we don't have the capability of taking a picture of one, so it's an artistic rendition of what a solar nebula would look like. I'll explain the orbital planes. So how does gravity affect planets' motion? So I was talking to you about the orbit earlier. So the sun has a very powerful gravitational pull on planets. That's obviously because it has the most mass. It's very massive. As we'll get later on, you'll see just how massive it is. And so if it has so much mass, then why don't the planets just plummet into the sun if it's pulling into it? Well, that's because they have a great vertical velocity.
Oh, shoot, that's right.
And it would be the ball, and then or the planet, and it's going past the paddle. But then because the paddle has more mass, it's pulling it in. But because my hand is moving so fast, in this case it's the sun and a planet, my hand is able to get around the edge of the paddle or the sun just quick enough or just fast enough to be in orbit around it and not just crash into it. Now, we say things like orbital speed and things like that all the time, but just how fast is orbital speed? Well, as you can see right here, a little bit below, the Earth is moving around the sun at approximately 67,000 miles per hour. And the closer planets obviously have to move faster. If you're closer to something, you have to move faster to get around it than something that's a million miles, or several million miles. The sun quicker, because in order to get around that loop, as I was talking about my hand with the ping pong paddle, it will move faster if you're closer, whereas if, say, Neptune way up here, you have to get a little bit slower. Right, you can be a little bit slower. So Mercury, closest planet, 111,000, about 112,000 miles per hour. And Neptune, the furthest planet, as I was saying, has an orbital speed of 12,000. So obviously a huge difference between the two. All right. All right, Zane, you can take over this one.
I want to fast forward a little bit. I had notes on, there was a few places where I was supposed to fast forward. This was one.
Okay, so this is Newton's cannon, and this is an experiment proposed by Sir Isaac Newton. And
orbital cannon is explaining how orbit works, as I was saying. A normal cannon, say, can fire the cannonball just short enough, but it's not fast enough to actually be in orbit. But so you see that first dashed line that shows, say a normal cannon, right? That's how far a normal cannon can fire one. But then say the cannon has more gunpowder in it. I'm not exactly sure what makes a cannon stronger, and it can go a little bit further. It's the second dashed line. But if we could fire a cannon at an unhumanly fast speed, it could actually get around the Earth in orbit like the moon is. All right, Zane, since you had a very short one there, you can explain tides.
how does gravity affect tides? The moon has a gravitational pull on the ocean, therefore it creates the tides. The tide is higher, the ocean is higher, at the location closest to the moon and on the opposite side of Earth. The sun also influences tides because of how far away it is. It has a much smaller impact on the moon. Our sun is 27 million times larger than our moon. Based on its mass, the sun's gravitational attraction to the Earth is more than 177 times greater than that of the moon to the Earth. If tidal forces were based solely on comparative masses, the sun should have a tide generating force that is 27 million times greater than that of the moon. However, the sun is 390 times further from the Earth than is the moon. Thus, tide generating force is reduced to about 59 million times less than the moon because of these conditions. It cuts off there.
Yeah, it's not because of these conditions. The moon has a stronger gravitational effect, or has a greater effect on tides. And as you can see in this picture to our or my right, you can see that in this picture, because the moon's off to the right, the arrows would be pointing to it. And as Jane was explaining, that the higher the tides is when the moon is directly opposite of you and when it's directly above you. So at midnight and 12 p.m. and 12 a.m., right, is the highest tides, because that's when the moon is above you and the moon's directly opposite of you. Now, low tide, think about how if you had water around a ball, right, or some sort of magnetism, and you were able to magnetize the water. If you had two strong magnets on either side, pulling it to those magnets, in between, when say at 6 o'clock, at 6 a.m. and 6 p.m., that's the lowest tide, because all the water is being pulled to the sides. I thought this model was just a good explanation of how those tides work. Black holes. All right, Chase, will you take this one?
Yeah, I'll take over black holes. When an incredible dense star collapses on itself, it creates an insane amount of gravitational force that pulls on the surrounding dust and gas, making a black hole grow in size and density. To give a perspective of how dense these stars are, imagine fitting 3 of our suns into the area of Tampa. However, we do not know how the black holes at the center of every galaxy, known as the supermassive black holes, form. These black holes are so massive because there are a lot of dust and gas at the center of the galaxy that these black holes can hold billions more times than our sun.
It looks like I forgot to put the word in there, but these black holes are billions more times more than our sun, billions times bigger and more massive than our sun, has more mass, right? I mean, and think about fitting 3 suns into Tampa. That'd be incredibly dense, and that's just right. That's just a stellar black hole. So imagine how dense the supermassive black holes are. And some people say that the supermassive black holes form by a bunch of stellar black holes colliding into each other. Some say just an incredible amount of dust, as Space was explaining. But we don't know, and we may never know. There's probably likely several reasons, because there are several. I mean, there's plenty of supermassive black holes in the whole universe.
I'm pausing for just a second. I was kind of looking at the questions that you're answering here. There isn't a specific question about black holes, but question number 2 that asks about what are a few things that gravity does in space. You're kind of filling in some of those answers, like they're going through several things that gravity does in space. Forming black holes is one of those things. Making the planets orbit the sun and how they orbit, is another thing. How the planets and stars are created. So the things that they're talking about in this presentation, you could list in number 2 some things that gravity does in space. Okay, so just making sure you're still with us there. I think you probably answered everything except 5 and 6, I believe.
Then wait. All right, Zane, you can explain this.
Gravity on other planets and how to calculate your weight on other planets. The more massive objects have a stronger pull than less massive objects. This is why you weigh more on larger, more massive planets like Jupiter, and less on smaller, less massive planets like Mars. We calculate weight by multiplying mass by the gravity on the surface of the planet. So if you know your weight on Earth and the surface gravity on Earth, you can calculate your mass. You can calculate your weight on any other planet using the surface gravity of that planet in the same equation. Weight equals mass times surface of gravity.
Right. That's not necessarily the equation, but right. That's just telling you what weight is. Some people may not necessarily know it. So as I think Miss Hughes was telling us in previous Zoom calls, that your mass does not change on other planets. However, it's your weight that changes, and it's because different planets have different surface gravities. I'm explaining to you that in a little bit as to why surface gravity. If, for instance, why is Uranus, which is huge, right? It's a very massive. It would weigh if you were.
Oh, this is the.
Had just a pure particle as close to the surface of a planet as possible. How fast would that particle be pulled to the planet? And that's basically how they theoretically calculate it. Obviously, you can't pull that experiment off on other planets, and it's very hard to do it on Earth anyway. So here is the ranking based on surface gravity. Now, as you can see, and I'm not sure if my part about Venus and Uranus having 100 pounds weight basically the same on both their planets. As you can see here, well, look at their surface gravity. Their surface gravity of Uranus and Venus are the exact same. Even though Uranus is, I think I have it in the later side, if not, it's several hundred times more massive than Venus. So I just think that's very interesting how the surface gravity is basically not affected by that.
And actually, I'm interrupting for a second. That has to do with the fact that Uranus is further away from the sun. So remember, distance also plays a role in gravity too.
And that's why you would weigh the same, because mass times surface gravity equals weight. So yeah, exactly. And then, as you can see, you can take a second to look at this. Take a second to look at this chart. Obviously, the sun has the most surface gravity by a long shot and everything. Thank you. All right. I guess I didn't have it.
Okay. All right. So, thank you, Zane and Chase and Alex for that presentation. It was good. There was a couple spots where Alex's voice fades out, and that's why I had to fast forward through a few things. But all right, so Jaden, what's your question?
Am I unmuted?
I have unmuted you now.
Okay. I just didn't get number 6. What is the difference between mass and weight? Which of these changes depending on your location, and why does it?
Okay, so Alex, I am going to unmute you. And so maybe you can answer that for Jaden. Jaden's wondering what the difference between mass and weight is and which one changes and why.
Okay, so what changes? Mass. Well, how massive is I'm not sure the exact definition of mass. However, your weight depends on your mass. Weight is your mass times surface gravity. And as I was explaining, your surface gravity changes on what planet you are and where you are. So if you looked at the charts, you could see that every planet had different surface gravity. So that determines weight. Now, I'm not sure the exact definition of mass.
So mass is the amount of matter in an object. And kind of gonna go back and see.
And the surface
There we go. So yeah, so mass, the amount of matter in an object, and then weight is how much gravity is pulling on that object. Yeah, so it's weight that changes with location, not mass, because there's different amounts of gravity on different planets depending on their location from the sun and how much mass is in the planet. Okay, so what other questions do we have? Let's see, do I have to stop share to see it? Okay, so Jaden, you can put your hand down unless you have another question. Courtney, what's your question?
I didn't get the answers to number 3 or number 5.
Okay, so question number 3, how does mass and distance affect gravitational attraction? Is that number 3?
Yes. Yes.
Okay, all right.
I can explain that. So your mass affects gravitational attraction because the more mass it's, like I was saying in the first slide, the law of universal gravitation, mass of something is, the greater gravitational pull it has. And as I was saying on the slide about tides, the moon, per se, is not as massive as the sun, but it's closer to Earth than the sun is. So therefore, it has a greater pull on Earth's water, giving it a greater effect on the Earth's tides. So the closer something is, the stronger the gravitational attraction is, and the more massive something is, the stronger the gravitational attraction is.
Excellent. Thank you, Alex. Did you get that, Courtney? I know there was a little bit of an echo. Were you able to catch that, Courtney?
Yeah.
Okay, great. Yeah. So, like he said, the bigger the mass, the larger the gravitational attraction, and the further the distance, the least amount. And if you look at the definition, it says that every particle attracts every other particle directly proportional to the product of their masses. So directly proportional means as one goes up, the other one goes up. So as mass increases, gravity increases. Distance is inversely proportional, which means as one increases, the other decreases. So as distance increases, the gravitational attraction decreases. And that is what Alex said. Okay. And Courtney also asked a question about number 5. Is gravity the same everywhere in space?
No, because if you're right next to the sun, which is something very, very massive, obviously, and the more massive something is, the stronger gravitational attraction, then there's going to be more gravity pulling you. If you're a million miles away from any star, and there's less gravity and nearly no gravity.
Right, exactly. Yeah, so the closer you are to a bigger object and the more massive the object is, the stronger the gravitational pull is. Yeah, okay. So it's not the same everywhere. So Courtney, don't forget to lower your hand if you don't have another question. I can do that for you. Okay. And any other questions? I don't see any other hands up. Okay. I think we've answered them. Great job, Alex, in answering those questions. And then let's go ahead and play the Kahoot. Now it's 1:15. We kind of started at 12:15, so we're right about at our hour now, or I don't know, maybe we probably have 5 more minutes, maybe. If you do have to go, I totally understand. You don't have to stick around. But I am going to play the last Kahoot, which is the Kahoot for this one, Alex's Kahoot. And so if you can stick around, let's play it. And then we will end after that. So, all right. If you have to go, I'll see you later. All right. So Kahoot it is. Let's go back to this one. Oops, hold on. Maybe I have to get out of my old Kahoot here. Oh, somebody's joining us right now. Oh, no, it's a chat. Okay. Oh, Alex says, can you clarify that I meant to say that the equation at the bottom is the equation? I won't play since I need it. Okay. All right. I think we got that. All right. So the other Kahoot should be right here, Gravity Kahoot. Hopefully you guys can see this. I don't know if you are seeing it or not. Alex, do you see your Gravity Kahoot showing on the screen now?
Yes, I do.
All right, awesome. Okay, let's get started. Here we go. There is our Kahoot pin. Go ahead and sign in. Remember, no bots, and use your actual name so I know who you are. And if you can't play, I understand. You can always just watch us. This is for the Gravity presentation we just watched. All right. Come on, get in there with Josh. There we go. There's Maddie. And Alex, you are welcome to play if you would like to play your Kahoot. You don't have to sit it out. I know John Ben was playing his Kahoot. Yeah, there we go. You guys getting in there. Okay. Let's see, how many of us do we still have? There's only 9 of us still with us today, so probably almost in there. We got 7 of you now. And, right. So let me know if you need a little bit more time or I should start it. So I'm looking right now. Raise your hand if you need another minute to get your name in. Oh, somebody left. All right, I don't see any hands up, so I think we're ready to go. Okay, we're gonna start. Are you ready for gravity? First question, who came up with the law of universal gravitation? I asked this question already, so you better not miss it. All right. There's even a little picture of him in the presentation and on my shirt, Sir Isaac Newton. And John Ben is in the lead, followed by Josh and Nova and Maddie and Alejandro. All right, question 2. What's a solar nebula? Well, is it a cloud of dust only? Is it a superhero? Is it a cloud of dust and gas? Or just a cloud of gas only? That is right. You all got that one. A cloud of dust and gas. All right. Leaderboard changed a little bit. Joshua bumped John Ben down to 2nd, followed by Nova, Maddie, and Alejandro. All right. Question 3. Gravity affects planets' orbits. True or false? True. Correct. All right, Ben went back in the lead with his streak. All right, question 4. How fast is the Earth moving around the sun? Oh, you had to be paying attention to that because you probably didn't write it down. It wasn't something you had to write down. Alex told you that that's the reason planets don't go crashing into the sun is because they're also moving at a pretty fast speed, 67,000 miles per hour. You're moving right now while you're sitting there. You're moving that fast. I bet it doesn't feel like it. All right. So, Maddie just made the lead now, followed by Saya, then John Ben, Nova, and Joshua. All right. Question 5. What is Newton's canon? Is it a thought experiment explaining cannons? Is it a thought experiment explaining orbits? Is it a thought experiment explaining how the planets formed? Or a powerful canon? It's a thought experiment explaining orbits, right? How planets orbit the sun. And they have to be moving at a higher speed to keep from being pulled in. Yeah, so Maddie is in the lead, followed by Saya, John Ben, Joshua, and Alejandro. All right, last couple questions. At what time is there high tide? Okay, Alex explained this one a little bit. This one was a little bit misleading because high tides can be at different times of the day, but in the model, they showed you, he explained at the 12 o'clock and the 6 o'clock for the high tides and the 9 o'clock and the 3 o'clock for low tides. I wanted to bring that up. It doesn't mean that those high tides and low tides are always at that time. That's just what the location of them on the model. So meaning from the top, so the 12 o'clock, if you imagine a clock pointing up, that's like at the North Pole, basically. But just know there's 2 high tides and 2 low tides every day, and those times do change, actually. So that question was a little misleading. Okay, so we've got Maddie still in the lead, but Nina has made it back up on the board. Sai is in 2nd, John Ben, and Joshua. All right, last 2 questions. How do supermassive black holes form? All right, Alex talked about that in some pretty good detail there. Is it dust collapsing on itself? Planets and stars collide to create it? Several black holes collapse in on themselves, or we don't know. And we did explain a few theories, and some of those were some thoughts, but the actual answer is we really don't know. But we do think that maybe several black holes do kind of combine to form a supermassive one. Okay, so Maddie is still in the lead, but you guys, and she's got a pretty good lead, but Saya and John Ben are kind of neck and neck there. We've got one last question. What is weight? Is it mass times surface area? Is it mass times 5? Mass times gravity? Or is it just mass? Mass times surface gravity. Yeah. Ooh, and pretty technical there. You got mass times gravity as another option. Surface gravity of the planet versus just gravity in general. So the red one was more specifics. That's the best answer. Let's see who won this game for some dojo points. Saya made it in 3rd place. 2nd place went to Maddie, and at the very end there, it looks like John Ben threw Maddie out of the lead and pushed her down to 2nd there with the last question. All right, and where's our honorable mentions? Oh, they didn't put honorable mentions down there, 3rd and 4th place. Okay, well, great. Thank you guys for playing, and I am hoping that you got something out of that. And I hope you are having a great day. Don't forget that this project space packet will be due Friday by 8 p.m. We have one more project to put in it. And that is Reese and Zoe and Saya's project that we're going to look at tomorrow, or not tomorrow, Friday. So don't forget to, if you have missed any of these, start getting the answers to any that you might have missed, either through our YouTube videos or ask a friend, you know, and sure. And yes, John Ben, you can stay after. I'll wait for you to talk. So, and if anybody else wants to talk to me at some point today, I'll be in my office hours at 2 o'clock. And so feel free to come see me there. And yeah. And yeah, I think that's about it. So if you need anything, come see me office hours or on EdSpeak, and I will talk to you guys on Friday. Otherwise, have a great day. Bye, everybody.